Today we will look at dot product of vectors, and we are going to look at it in terms of trigonometry. So it's going to have some to do with the trigonometry. So sometimes dot product is called scalar product because the answer to a dot product of two vectors is a number. It's not a vector. So let's look at it. I will look at two vectors. So make sure that you watch the vector video before you do this. And then you have a V and a W, and then they have an angle in between. So let me try to write down what V dot W is. That is the magnitude of V times magnitude of W times cosine of theta, which is the angle in between. Also, you can go and I will just put a couple of things in here, some notation in terms of vector. So the magnitude of V is simply written like this, or you can also write it like this, thicker V to show that it's a vector, or double thicker V. Okay, that is simply if my V has the coordinate of V1 and V2, it is simply square root of V1 squared plus V2 squared. Okay, what is V1? V1 is number, and it is the magnitude of my vector times cosine theta. And then V2, if I have some like this. Let's not call it theta, but call it, I don't know, gamma or something. Okay, so if this is my V, and this is my V1, and this is my V2. So V1 is magnitude of V times cosine gamma, and V2 is magnitude of V times sine gamma. So I define this, this, and this. And you can do something similar with W. Now, let's go back to dot product. This is my first equation. This is the second equation. The V dot W is also the same as taking V1, V2 times W1, W2 in the vector notation, and that is simply equal to V1 times W1 plus V2 times W2 in terms of numbers. So this one is your second equation, and this one is your first equation. So let's put first and second together. So when you take the dot product of two vectors, it is V1 W1 plus V2 W2, which is the same as magnitude of V, magnitude of W, times cosine of theta, which is the angle between the two of them. Alright, this is what you need to remember. Now, what is the application to trigonometry? It is fairly simple since it involves the cosine of theta. Maybe somebody may ask you, what is the angle between two vectors, and giving you the vectors themselves. So I will use this example. Let's say my V is 2, 3. I can also write this as 2I plus 3j in a plane that is I and j, where those are my unit vectors. And then my W is simply, let's say, 2j. That means I do not have any I, so that's going to be 0, 2. So if I want to draw these vectors, they will look something like that. V is 2, 3, 1, 2, 1, 2, 3. So my V goes like that. And my, so let's show that. And my W is going to be in red, and that's going to be 0, 2. Here we go, 0, 2. That's my W. So, and this one is the angle in between. Okay, and somebody's asking, what is the angle in between? So, let's go and pull this out from this equation. I know that V dot W is simply V W in terms of magnitude and cosine theta. Pull the cosine theta out of this. You'll get V W divided by magnitude V, magnitude W. So all I have to do is just do some algebra here. V dot W is simply, what was it? 2, 3 times, dot product, 0, 2. And let's look at the magnitudes. What is the magnitude of V? That is simply 2 squared plus 3 squared. And that turns out to be 9 plus 4, 13. And in terms of W, that is simply 0, 2 squared, which is 2. So this is going to be rad 13 times 2. Okay, well, let's clean it up a little bit. What was this about? 2, 3, dot product, 0, 2. And remember how the dot product worked. This times that, that's 0. Plus 3 times 2, that is 6. So that gives me 6. So let's write this out. So I have a 6 on top, and I have a 2 at the bottom, and we're at 13. Oh, okay, this is good to know. So that is, so I have a situation, I have a trigonometry problem. Cosine theta is simply 60y2, that's 3, over rad 13. Okay, so you can go and take the cosine inverse with your calculator of 3 over rad 13, and that's going to equal the theta, and that I just plug it in and I get 33.7. So I actually found the angle between the two vectors. Another application might be scalar projection of a vector onto another vector. So let's look at that. What does that mean? Let's say I have projection of A onto B. What that means is, let's say I have an A vector and I have a B vector, and in terms of, you just draw a 90-degree, and this is exactly what we are talking about. This is the scalar projection of A onto B. Okay, so, or you can call that component of A along B. Okay, and how does that work? Component of A along B, and look at it. That is actually the dot product of A and B divided by the magnitude of B. Alright, so let's look at that. If I have a situation of A equals -2, 5, and B equals 3, 4. Okay, and you can have component of A along B is going to be equal to the dot product divided by magnitude of B. Okay, well, let's write the dot product. Negative 2 times 3 plus 5 times 4. Magnitude of B is simply 3 squared plus 4 squared, and that turns out to be 14 over 5. So this is another application, but usually the dot product is used to find angles between two vectors.